So in this session, we are going to talk about variables in C programming language. So variables are essentially storage locations. So whenever we perform some computations, let's say, so some series of computations, now before producing output value, we need to store the the data that is calculated on temporary basis, right? That is during the program execution. So in C programming language, these storage locations which is present in the memory are termed as variables. Now variables are what? Whatever memory locations are there. So we know that very well that memory locations are used to store data and instructions. So those memory locations where we store values, these memory locations are provided some names, and these names are identifiers in C programming language. So these are variables. So variables are named memory locations. Next, so a variable can be thought of like a bucket. So like in the container or in a bucket, there will be some content. Similarly, in a variable, it will have a value. Like in the world of mathematics, a variable takes the value from its domain. So similarly, variable can take acceptable value from the data type, right? So we have a bucket. So a variable is similar to bucket. So bucket can contain something. So similarly, a variable can contain a value. Now, the variable name is used to refer to the value of the variable, right? For example, in the world of mathematics, if I have a very large number, so that very large number can be represented by variable name. And if I talk about memory storage, so variable is mapped to a location of the memory, and that location of the memory in the jargon of C programming language, we call it memory address, right? So without showing much of theory, we'll get into the practical aspect. So how do you create a variable? So first of all, I will need printf. So I'll use the signature for that, that is const char pointer. This declaration is something that we'll be discussing later. You can also use hash include stdio.h header file as well. Integer main, and this main must not take any parameter, so void. Now here integer a. So this is my variable, right? So a is the variable name and this is the data type. That means the domain. So here a can store integer. So in order to print this variable a, so we can write value of a, and in order to print an integer value, we use percentage %d as the format specifier, and here variable a. Similarly, every variable has an address. So in order to access the address of any variable, we use the operator address of, right? And in order to print the address of a variable, we use the format specifier as percentage %p, right? So first of all, I will just compile this code. Maybe previously you saw one value, right? So here the value of the variable is 89 and this one is the address. So as many number of times you compile, the address will vary. Like here 70D8C and here it is 3ED7C, right? I'm not reading the full address because it is lengthy actually. If I execute again, the value remains the same because I haven't modified the value here, but the address changes. So every time your program exits and you load the program again and again, the address changes, right? So this address is assigned by the operating system, or you can say the execution environment in which my C program is executing, right? So this is how we get the value and this is how we get the address. And in order to get this data, that what is the size of A in memory, that means how many bytes are allocated for this one. So for that we use this format specifier ZU, and we will write here size of the variable name. So on 64-bit architecture, if I compile and execute, the integer takes 4 bytes. Similarly, if I take another data type, let's say long, so if I compile and execute, so it takes 8 byte. Similarly, if I take short integer, so in that case, if I compile and execute, so you can see it is 2 bytes, right? So I can take this different data types. So definitely in the upcoming discussion, we'll talk about data types in more detail, right? So that's the idea of variable. So we observed clearly that how can we get the value of the variable, then size of the variable, right? And as well as the address. Now, so variable declaration. So what is this declaration, right? So in C programming language, it is important that all variable, any variable that you want to use, like for this example, like Fahrenheit, Celsius, lower, upper step, these are having the data type and these are the variable names if you can observe. So every variable must be declared before they are used, right? So declaration talks about, it announces the properties of the variables. That means what will be the data type and the variables, right? So that's the idea of declaration. Without declaration we cannot use variables actually, right? Now next is the definition. So variable declaration is something that that informs the compiler the name, type and other attributes of the variable, whereas the declaration says that that it will just talk about this thing, that how the compiler is going to allocate memory for that variable. Now one question that comes in mind is that if the program has not yet executed till now, then how come compiler allocate memory for that program, right? So the memory for this variable like a, this will be allocated memory only during the execution. That means if I hit compilation, let's say if I just hit the compilation, then only the object code, or I can say the executable code that is generated here, right? So if I write here, let's say file hello, so this is the executable file, right? This hello is the executable file. So when this executable code is loaded by the operating system loader, only in that case the memory will be loaded, right? Then why this question, or why this concern that compiler allocates memory? So what does it exactly mean? So this is something that we are going to address in our upcoming discussion. For time being, I would request that you can comment below your thoughts regarding this, right? Okay. Now for every variable we know that we can during the declaration time we can assign the value, then we can print the value of the variable, and then we can print the address of the variable, and using size of operator we can get the number of bytes that is allocated for a given variable. Next, now the next part is variable initialization. So it says that during the declaration along with the declaration, if the initial value is assigned to the variable during the declaration time, then this concept is called initialization. For example, like if you observe this line number 4, if you observe this line number 4, this is a initialization statement. That means during the declaration when I assign the value, then this is called initialization. But if I write, let's say a assignment 78, I'm just modifying this, right? So this is not initialization. This kind of statement is called assignment statement. That means you have written the assignment operator. Using the assignment operator, I have assigned 78 to this variable a, and I have put semicolon here. So this statement is not initialization. Why? Because I am not declaring data type here, right? So when you are modifying the value of the variable using assignment operator, such kind of statements are called assignment statement. But during the declaration of the variable, when you are assigning the value of the variable for the first time, this is called variable initialization, whereas if you observe this line number 9, it is 78. So you can observe, if I compile, and execute this one, right? So you can see initial value is 89, and you can observe after the modification the value of a becomes 78, but the address remains the same. That means once the address whatever is allocated, you modify your variable any number of times, the address remains fixed. The address will only change, sorry for this thing, okay, the address will only change when the program exits and you're loading it again for execution. Only in that case the address gets modified. Otherwise, when your program is under execution, once an address that has been assigned to a variable, you can just change the value of the variable but not the address, and you can see the size of a also remains the same, right? So I hope that is clear. So I hope the clarity, the difference between variable declaration and variable initialization is clear to you, everyone, right? Now, so these are the examples. So variables may be initialized either at the time of declaration, right? So you can observe, so these are the variables that during the declaration. In the declaration, data type is compulsory. After the data type, when you mention the variable name and then you are assigning the value, this is your initialization. But later on, if you change the value, that is, or so either you can initialize the value during the declaration time. This is one example, or they may be assigned values. How? Like this statement. So I have assigned, I have performed assignment here. If I try to do this thing that I am declaring this again, so in that case I will get compile time error. So it says that redefinition of variable a. So in the same scope, that means within this body of main function, you cannot define variable with same name. So you're going to get a compile time error called redefinition of variable a. This is not allowed, right? Okay. So in that case, this is initialization, but this factor is now, this particular statement at line number 9 is my assignment statement. I repeated this lot of number of times, right? Now the question is, if you are not initializing, let's say if you are not initializing a variable or you are not assigning a variable, so in that case what they will contain? So they will contain some random values. So what I mean by that, so you can observe here, this is a variable, it is just declared and defined, but it is not initialized. So you can observe it is printing something random. So let us have a look. Let's say if I do not initialize this a, if I do not initialize this a, let me compile and execute. So you can observe here, because of this assignment at line number 9, this 78 is printed intact and the address also remains the same. But you can observe here, this value 32659, this is a random value. This value is something that I haven't assigned. So the execution environment automatically captures this. So this is random value, or also termed as garbage value. So every time I execute, I'll get different value. So you can see this is different from the next execution. When I execute this again, you can observe this is different again here, right? So because of this random behavior, it is always recommended that whenever you have to use variables in C programming language, it's always better to initialize with some value. If it is for, if there is no clarity, then you can initialize with 0, or depending on identity of the system that you are developing, right? So these are the examples, right? So if you take a variable and you are not initializing it, then these variables will contain garbage value, or you can say random value, right? So this statement, like you can observe here, so this is a initialization statement, right? So if you observe, if you just forget about the semicolon for now, this statement, this expression is an initialization expression, and expression becomes a statement when you apply semicolon, right? So in the jargon of C programming language, this 8, which is used to initialize this variable height, this is said to be initializer, right? So the expression that is initialized to a variable is termed as initializer in the domain of, or in the jargon of C programming language. Now next one is variable assignment. This is something that we have already discussed, right? So these are some of the assignment statement, and make sure this thing, without variable declaration, assignment has no meaning. For example, let's say, let me remove this part. If I write, let's say a assignment, let's say 34. So in that case, I have not declared it. Without declaration, I'm trying to assign it. So definitely I'm going to get compile time error. So you can clearly read this, that a variable, so you can observe the identifier is undeclared. So first use in the function, right? So in that case, undeclared identifier you cannot use, right? So you have to declare it. So either you declare it here int a, and then you can use it. So compile and execute, it won't generate any output because I've not printed this, right? So that is what I mean to say when I say that variables cannot be used without declaration, right? So these assignments are possible, height, length and width, if they're declared. So after declaration only you can perform assignment. So keep this thing in mind. Now this is the assignment statement, that is after the declaration. After the declaration, you can mention the variable name and you can write an expression. For example, let's say this is the variable a, and the expression, that is, let's say 34 plus 9 times 7. So this is the expression. So first of all, this expression will be evaluated, and whatever is the answer, that will be at last assigned to this variable a, right? So we'll talk about operators as well for more clarity. But remember this thing, assignment occurs at last. First of all, the expression will be resolved, and after that the assignment will take place, right? So now the thing is that some of the variables are automatically set to 0 when the program begins to execute, but this is not always the case, right? So variable does not contain default value, so that can be accidental value. Now if the variable is not initialized, then such kind of variables are called uninitialized. And we already observed this thing, that if I try to access uninitialized variable, then in that case I'm getting random values or garbage values. So that's about variable. So after this, I hope the objective is achieved, that how can we create a variable, how can we initialize the variable assignment, how to fetch, how to print the value of the variable, how to get the address, and how to get the size of a variable. So these are the objectives which we have achieved in this session, right? So I hope everything is clear.